Today we're going to talk about exponential functions. An exponential function is a function in the form of y equals a times b to the x power. X is always going to be your variable. And this is just saying a is greater than 0, so you can't have a be 0 because then it would be y equals 0. B is greater than 0, and b cannot be 1. Because 1 to any power is always 1, so it doesn't work. The exponent is a variable, so that x is always a variable. I think I already said that. Okay, so here it is again, a little bit clearer, and this time it doesn't have the dot, so we all know the various ways we can write that to indicate multiplication. A is the y-intercept. A is the y-intercept that occurs when x is equal to 0. That's the definition of y-intercept, so that's what A is, y-intercept. B is the factor the function increases. Factor is what you're multiplying by. Exponential functions are nonlinear, and change may be made by equal factors over equal intervals. So x increases by the same amount, like plus 1 every time, or plus 2 every time, or plus 3 every time. But y increases by a factor. So y is being multiplied by the same number each time. Okay, so is this a linear or exponential function? Okay, so we have to look at how y increases. Plus 1, 1 to 2 is plus 1, 2 to 3 is plus 1. 2 to 4, okay, that could be either times 2 or plus 2. So let's go to the next one. 4 to 6 is plus 2, 6 to 8 is plus 2, so now I know this is actually plus 2. Okay, so if I look at it, this is increasing by the same amount every time. This is also increasing by the same amount. Adding, not multiplying. So it is a linear function. How do you know? Because you have a constant rate of change. Your slope is 2. Because remember, slope's change in y over change in x, which simplifies to 2. All right, so now let's look at the next one. How does x increase here? Plus 1. How does it increase here? Plus 1. How does it increase here? Plus 1. Okay, so that doesn't tell me anything. Now I'm going to look at my y's. From here to here, okay, it's either plus 4 or times 2, so I have to look at this one to figure it out. Okay, so that is definitely times 2. It is not plus 4. So then this is times 2. Okay, because you're multiplying, you know it is an exponential function because y increases by a factor of 2 each time. So that's how you know it's exponential. Okay, evaluate each function for the given value of x. So this is my function. This is my given value of x. You are going to plug 3 in for x in this function. So y equals negative 2 times 5. X is being replaced with a 3. Okay, order of operations. We do exponents first. So that means I have to do 5 to the third power. 5 to the third power is 5 times 5 times 5, 125. So y equals negative 2 times 125. Y equals negative 250. So that is your function evaluated when x is 3. Okay, so to make a graph, make a table of values. And I'm going to use the terms, the numbers negative 3, 0, and 3, just because the way this is written, I remember my format is a b to the x power, and my a is my y-intercept. So this is where my y-intercept is because my a is 1. That is 1 times 2 to the x power. When it's not there, it is 1. Okay, so when I do my chart, that should coincide with my y-intercept because I have it here. All right, so now I'm going to plug in y equals 2 to the negative third, which is y equals 1 over 2 to the third power because that's a negative, which is 1 over 8. So I have negative 3 comma 1/8. So negative 1, negative 2, negative 3, 1, 2, 3. Okay, negative 3 and 1/8. It's really close. And now I'm going to do 0. That's negative, not a negative sign. So y equals 2 to the 0 power. Anything to the 0 power is 1. So 0 comma 1, which I already have because I already recognize that that was my y-intercept. Now y equals 2 to the third power. 2 to the third power, 2 times 2 times 2 is 8. 3 comma 8. 3, 4, 5, 6, 7, 8. Okay, now I'm going to connect my dots. I don't have to worry about using a line. Okay, here's the thing. Written like this, it took me a long time to formulate that thought, didn't I? Your y will never be less than 0 because there is no exponent of x that would give you a negative number. So as you go to the further left, you just get closer and closer to 0. Oops, that was a nasty line. Nasty, totally missed my dot. Ah! You get closer and closer to 0, but you do not hit 0. Okay, so I got closer and closer to 0, and then I just connected my dots, and it's not a line. Okay. So there's my graph. Now, describe my domain and range. We remember that our domain are our x values, so that means we have to look to the right and to the left. So to my left, I would go to negative infinity. To my right, I would go positive infinity. So your domain is all real numbers. Your range is your y values. I will never ever be, I'll never be able to hit that 0. So y is greater than 0. And that means it's going to go forever and ever and ever positive. All right, so now we're going to graph this one. I am going to, let's see here. I'm going to put, we already graphed this one. So I'm just going to put that back exactly how it was on our previous slide. Okay, now I'm going to graph this one using a table of values. And I'm going to use my same x values because I'm comparing it and I want to make sure I compare correctly. So I'm going to use my x values of negative 3, 0, and 3. So I'm going to plug it in. Y equals 2 to the negative third power plus 3. Negative means I have to kick it to the denominator. So that is 1/8 plus 3, which is 3 and 1/8. So it's negative 3 comma 3 and 1/8. Negative 3 comma 3 and 1/8. 1, 2, 3 and 1/8. So there's my point. What's your point? Oops. Okay, now x is 0. Y equals 2 to the 0 power plus 3. 2 to the 0 power is 1. 1 plus 3 is 4. So my other point is going to be 0 comma 4. Then positive 3. Y equals 2 to the positive 3 plus 3. 2 to the positive 3 is 8. 8 plus 3 is 11. So 3 comma 11. 8, 9, 10. Oh, I have to put it up there. And let's see here. I know I'm never going to cross this one because I always have a plus 3, so I'm never going to go below that. Okay, now if I compare the two, if I just look at these numbers even, I should be able to see what it is. So it was 1/8, now it's a 3. What did I do to it? I added 3. This y-intercept was a 1, now it's a 4. What did I do? I added 3. This was an 8, your y value, now it's an 11, so what did you do? You added 3. So this is 1, 2, 3, this is 1, 2, 3, this is 1, 2, 3. So I can see every time I added 3. Other than that, it's exactly the same. So y equals 2x plus 3 is a translation. Remember that? Translation. 3 units up from y equals 2 to the x power. The domain are your x values. So you have to look to the left or to the right. So to the left goes to negative infinity. X is greater than that. X is less than positive infinity. Your range are your y values. So we are describing the domain and range of our red one. And it gets close to y equals 3. But it never hits y equals 3. So your range is y is greater than 3. Okay, I'm not going to do this one because I think they're stupid. I'll explain it to you real quick if you want to. Okay, but this is important. This is your normal equation, right, for an exponential function. But when you add a constant to it, it'll either go up or down. It'll go up if you add your constant. It'll go down if you subtract your constant. Okay, so on this one, what's your y-intercept? Well, it's what's in front of here, so that would be a 1. So your y-intercept is a 1, but then you subtract 1, so it brings you down to 0. So your k value is from here to here. Okay, so that's going to be a 1, 2, 3 plus 3. Your k value here, we start here because that's this equation, and then we're going down 2, so your k value is negative 2. Okay. Where's our normal equation? A is the y-intercept. Y value in x is 0. B is the factor the function increases. Use the table below to write an equation. So you're going to need a number for A and a number for B. A is your y-intercept. It occurs when x is 0. Hey, x is 0. So now we know our A is your y value when x is 0. So your A is 2. Your B is the factor that this increases every time. So what do you do from a 2 to get a 10? Times 5. What do you do to the 10 to get a 5? 50, sorry, times 5. 50 to 250 is times 5, so we're good. So that means our B is 5. Now we're ready to write an equation. Y stays y equals our A is 2, because it's your y-intercept, times your B is a 5, and then your x stays an x. So your y and your x stay as your variables, and you have to find your A and your B. Your B is what you're multiplying by each time for your y. Your A is your y when x equals 0. All right, the graph represents bacteria population. Y is population after x days. Okay. Write an exponential function that represents the population. What is domain? What is the range? So first we're going to write our exponential function. So generic form, y equals a b to the x power. And we need to find a and we need to find b. A is your y-intercept. B is your factor that you're increasing your y by. So let's look at the graph. A is my y-intercept right there. My y-intercept is 3 because it occurs when x is 0. So my A is 3. My B is my factor that my y increases every time. So I go from 3 to 12. What did you do to your 3 to get a 12? I don't know, either add 9 or multiply by 4. So let's look at this one. From 12 to 48 is definitely not adding 9, so now I know it is times 4. So this is times 4. From 48 to 192 is times 4. So now I know my b, what I increase my y each time, is 4. I'm ready to write my equation now. Your y stays y, our a is a 3, times our b to the x power. And, okay, don't be silly. You cannot multiply those. You cannot simplify that because they do not have the same basis and they do not have the same exponent. So if this was 3 to the x times 4 to the x, yeah, then you can have 12 to the x, but it's not. So this is its most simplified form because they have different exponents. Okay, so now let's look at the domain. The domain is, let's see here, domain is x. X is the number of days. Number of days has to be a positive number, so we're looking at our x value, so we're going this way. How far to the right can it go? It could go to infinity, but it doesn't because it stops right here. So right here is where it stops. Your x is greater than or equal to 4. That's the domain. Your range is looking up and down, but you cannot have a negative population, so you have to look up. I have a mess here. I can't read this. So the smallest y is this one. So your range has to be y is something compared to 3. So I see it is 3. So y is greater than or equal to 3. So your range is population. Population has to be greater than 0. And then I looked over here at 0 days. You start with 3. So y is greater than or equal to 3. Okay. So hopefully you understand why you have that as your domain and range. And that is not a 1 that was in front of it. That red one was a circle that I didn't get to erase. All right. The graph represents bacteria population. Find the population after 12 hours and then after 5 days. Use the formula from the previous slide. So our formula from the previous slide was y equals 3 times 4x. Y is population, x is after days. We have to find the population, so that means we have to find x. So 12 hours. All right, x is days, so I have to convert that to hours. To days. So 12 hours is how much of a day? 12 over 24 is half day. Okay, so now I know my x equals 1/2 because my x is my days. And 12 hours is a half day. So now I'm going to substitute that into my equation. Y equals 3 times 4 to the 1/2 power. Okay, whenever you have a rational exponent, we remember this is the index and this is the exponent. So what we really have is y equals 3 times square root of 4 to the first power. And I'm not going to write to the first power because I don't need to. All right, so now I'm going to simplify. Have to do my square root first. So it's 3 times square root of 4 is 2. So y equals 3 times 2. I can multiply it now. 3 times 2 is 6. Okay, and then my sentence is, after 12 hours, there are 6 bacteria. That doesn't sound too bad, does it? All right, so I'm going to erase that now because we're going to do the 5 now. So why don't you do the 5 and see if you get what I get? Did you get 3,072? So my sentence is, after 5 days, there are 3,072 bacteria. Ew, gross. Period. All right, and that's it. When asked to create a graph, you can use your graphing calculator to check. Only to check. Make sure you do it without your graphing calculator, and then check with your graphing calculator.